Factor perfect square trinomials. We can factor perfect square trinomials using the methods which we have just seen in the previous videos, but in many cases we can factor them more quickly by inspecting their terms and applying the special product rules in reverse. What are they? So the perfect square trinomials, let us go with those ones here. Consider that I have a squared plus 2ab plus b squared. That gives us a plus b squared. Okay, be careful, the square is on the bracket. Let me expand in with the screen. All right, and each of these trinomials factors as the square of a binomial. All right, so I also have a squared minus 2ab plus b squared, that is equals to a minus b. Now from observation, I want you to notice that the negative is here, the negative is here. There's no negative here, there's positive here, and we have a positive value, right? So the only difference is the middle term that changes sign. So when factoring perfect square trinomials, it is helpful to know the integers that are perfect squares. What are perfect squares? Well, I just showed you a while ago. The number 400, for example, this number here, for example, 400 is a perfect square, is a perfect integer square. Let me write that down. Is a perfect integer square. Now remember, perfect integer, very important, okay, that are perfect squares. So this is a perfect square number. Now what does that mean? This simply means that 400 could be written as, can be written as 20 squared. That is also 400. So let me give you examples of basic perfect squares. Okay, so these are a few examples. So I can have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 196, 225, 256, 289, 324, 361, and 400. Okay, this could be written as 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 square, 14 square, 15 square, 16 square, 17 square, 18 square, 19 square, and 20 square. Sorry about that, it wasn't zoom out too much. Zoom in again. Okay, so those numbers could be written in that form. Okay, now by doing this, I want you to note carefully that once you see these numbers, you should know that they are perfect square numbers. All right, so let's try a few examples. So examples. You say factor, okay, x squared plus 20x plus 100. That is our problem that we need to solve. So our strategy here is that the terms of each trinomial here do not have a common factor other than 1. That's for sure. We will determine whether each is a perfect square trinomial. That's our key point here, to determine if it's a perfect square trinomial. Why? If it is, we can factor it using special product rule in reverse, right? Which we will see in a little while. Our solution then. So let me start with the problem. So we have here x squared plus 20x plus 100 is a perfect square trinomial. Okay, this is a perfect square trinomial because, okay, because one, the first term, I want you to notice it, first term x squared is the square of x. 2, the last term 100 is the square of 10. Thirdly, the middle term is twice the product of x and 10. Remember, twice, which means 2 times the product of x and 10, such that 2 times x times 10 equals 20x. Notice that. Okay, to find the factorization now, we need to match to the proper rule for factoring a perfect square trinomial. So let's see. We have here, okay, we'll have our problem. So we have here x squared plus 20x plus 10 squared. We have put them in squared form. So we have now here x squared plus 2 times x times 10 plus 10 squared twice. Remember, this is the middle term for 20x. So we put here now a squared plus 2ab plus b squared. This is this form here. Okay, this one here, we put them in this form. So we have done that. So notice now, we have taken our value. Let me zoom in there. We have taken x squared 20x plus 10. We take the first term and we square it. We take the second term and we square it here. Notice. So now our first term is x and our second term is 10. So what we are going to say, we're going to say twice 2 times this once we have identified them. And by doing that, that should give us our middle value of our trinomial, which it does. Therefore now, we have x plus 10 squared, which is a plus b squared. So it is a perfect square trinomial. Okay, so that's how we get that one there. All right, let's go with the next one. So b, we have 9x squared. Let me zoom in. We have 9x squared minus 30xy plus 25y squared. Note carefully where we have variables. We have in the first, the second, and the third term of the trinomial. Is this a perfect square trinomial? Yes, it is. All right, just from observation, I could tell you it is a perfect square trinomial. And let's see why. Is a perfect square trinomial. Okay, the first term 9x squared can be written as 3x squared. The last term could be the 25y squared could be written as negative 5y squared, and the middle term is twice the first times the last term. So let's see, twice. So how do we get the twice? We get 2 times the first term, which is 3x, times the last term, which is negative 5y. Let's see if that is true. 3x squared will give us 9x squared. 2 times 3x, 6x, times negative 5y, negative 30xy. So that then the next one will be negative 5y squared will give it 25y squared. Therefore, this is a perfect square trinomial which works out to be 3x minus 5y open close bracket, and we put it square. So it is a perfect square trinomial. Okay, so let's go with the next one. So let's see how this next one can work. Our next example will be 4a cubed minus 4a squared plus a. Okay, now we will factor out the greatest common factor first of all. Every time you are working with trinomials, binomials, or whatever, if something can be factored out, you go ahead and factor it out. So what do they all have in common? A. Okay, so factor out the a. So by factoring out the a, this is what happens. This is how the problem looks afterwards. We have a 4a squared minus 4a plus 1. Okay, so now this problem looks more beautiful, right? So let's see. The 4a squared minus 4a, this could be factored out as to say a, you put the bracket, this could be written as 2a squared, this could be written as plus 1 squared minus 4a, that could be 4a for the meantime. Okay, now see what happens here. We have a, according to our rule, we put 2a open close bracket squared, and we're going to put twice the first term times the second term of one of the binomials, and in this case one of them has to be negative, so let's make the one negative 1, because when you square negative 1 it will become positive 1, which we need here. That becomes negative 1 plus negative 1 squared, so we put plus here. Now that now gives us a open bracket 2a minus 1 open close bracket 2a minus 1 close bracket, or you may state it as a open bracket 2a minus 1 squared. Okay, that is how you can state that particular problem there.